Hello everyone, we are gonna learn today how we can create a pressure swing distillation unit on Aspen Plus. So let me open a new template first. Then we are gonna identify the components. The first one should be methanol and the second one should be chloroform. Let me change the unit first, then we can go. Methods, these should be all. These should be nr, tl, rk. Okay, parameters should be calculated by itself, as I said. Okay, these are good. So I want you to see the physical properties of pure components. I'm gonna show how you can see all physical properties of the components. You can go here and say retrieve parameters, then say OK, then you should say yes. Here it shows the physical properties of the components. For example, this is critical temperature, this is critical pressure. I don't even know what they mean for each one, but how you can find it, you can go help section and say parameters of pure components, then search. You're gonna find some index here and you can check, for example, critical temperature TC or dipole moment map is here, etc. You can find it like this. And before going to the simulation section, I want you to see also TXY diagram of the components. So you can see, I'm gonna choose TXY and two components, methanol and chloroform. This is the mole fraction. So this should be from 0 to 1, but you can focus on a specific range, is up to you. I'm gonna make it 100 because I don't want to get garbage results. So we can add two different pressure values here, 5 bar and 10 bar. In calculation option you can change the phases, but I'm gonna leave it like this so we can run it. So you can use this diagram to make estimation of physical properties of components without creating a flow sheet. So this graph shows the correlation of temperature values, pressure values, and mole fraction. For example, for each curve, the top line shows the dew point and the bottom line shows the bubble point. And if vapor and liquid curves are getting closer, it means you need to add more stages for distillation. Also, if they meet at a place, it is called like azeotrope, but it is commonly used also pinch point. So you can use these terms. I think that's all for this graph. So we can go to simulation section. What we are gonna add, red flag for distillation column. Okay, then a feed stream. So we can type here feed. Then we need to add to outputs. For the inputs of the red flag, let's say 35 stages here. Condenser should be total. This should be boil up ratio. 3.2, reflux ratio 3.2 as well. Streams, feed stage should be 15. Pressure should be 1.1325 bar, and we can put the input of the feed stream as well. Let's make it 30 Celsius. Then same pressure value. Let's make it 200 kilomole per hour. And components, 70% for methanol and 30% for chloroform. I think everything seems good right now. We can run it. Let's see if that works or not. Okay, there's one mistake, I think. Let's see what's going on. Okay, so it's about convergence. Okay, this should be higher. Let's make it 200 and run it again. Yes, that works. So everything seems good now. We can add a pump here. Now let's increase the pressure of the stream to 10 bar. Let me check. Yeah. Okay, the pressure is 10 bar and the temperature is 55 Celsius right now. So we can add the second distillation unit. Okay, it should be here. For the second distillation unit, it should be azeotrope right now. Azeotropic. Number of stages 35 again. It should be total. Boil up ratio. Boil up should be 7. It should be the same. 3.2. I didn't add the streams. Let me add these streams first. Okay. Okay. So let's make it 15 again. Pressure should be 10 bar now, and I think this should be an input for the first distillation column, like recycle. Okay, everything is fine, I think. Let me check it again. Okay, this is fine. Okay, let's run it. This should be also 15. Okay, so we can see the results right now. So we can check the streams. So we can see the results here for each stream. I think it's so clear for you all. You can see mass flows, mole flows, or mole fraction, mass fraction, or enthalpy, density, etc. So I think that's all for the second tutorial. Thank you for you all for watching. See you next time.